So, students, I was talking about non-linear partial differential equations f of x, y, z, pq equals 0. I have already told you that there are four standard forms. When z is px plus qy f of pq, which is known as Clairaut's form, it is solutions given by z equal to ax plus by plus f of ap. Okay, then you have standard form where only p and q there. You see, x, y, z, p and q are present. In this Clairaut's form, all the components are present. X, Y, Z, P and Q. Here only PQ is present. PQ are present. Here PQ, Z are present. So here X, Y and Z are absent. Here X, Y are absent. Then you have Z is absent. X, Y, Q and P. And these are such equations which can be separated. P and X and Q and Y. So these four methods I will be showing you today. And then Charp's method, which is the general method for solving such equations. Okay. Now, first one is very easy. If you will take Charp's method, say you have standard form 1 z equal px plus pqy under root of pq. This is of the form z equal to px plus qy plus function of pq. So, complete solution is given by z equal to ax plus by plus under root of ap. This is the solution. Conversely, if we will take this as a function ax plus by plus root of ab, and if we are supposed to find the form a partial differential equation by eliminating arbitrary constants, you could see del z by del x is a, so p is a, and q, which is del z by del y, is b. So p is a and q is b, so that is it. Another question says z equal to ax, px qy plus under root of r p square plus q square plus 1. You see, this is again Clairaut's form, z equal to px plus qy plus function of pq. So what is the solution? Solution is ax plus by plus a square plus b square plus 1. So the solution contains as many constants and as the number of independent variables. This is known as complete solution. There is another solution, singular solution, general solution. We are here only to find the complete solution. Complete solution is that it contains as many constants as the number of independent variables. So two constants will be there. Next, this was f of p, q, z, x and y. Now let me take up f of p, q, x and y equals 0. Only z is absent. Or this form is like this also, can be written in this form also, f2, y and q. Right? For example, let me take up, say you have, let us take, okay, x 1 plus yp plus y 1 plus xq equals 0. See this, you have x, y, p, x, y, p. No z is present. So let me write down in this form, x equal to minus y 1 plus xq. Or let us keep x and p on one side and y and q on another side. This is it. So this is f1 xp, f2 yq. Now how to solve this equation? Now you have f1 xp equal to f2 yq. Let us suppose that they are equal to a, say a constant, arbitrary constant. This gives us, this means x upon 1 plus x into p is a, means p is equal to 1 plus x by x into a. Similarly, q is a times 1 plus y by minus y, right? So this is it. P is 1, A times 1 plus x by x, Q is A times 1 plus y by minus y. Or your P is 1 or A times 1 plus 1 by x. Q is A times or minus A times 1 plus 1 by y. You can take this minus outside, so Q is minus. Now, I will use the formula dz is equal del z by del x dx plus del z by del y dy. This you have done in your first semester. Or this is P.D.E plus Q dy. So let me substitute P and Q in this. So I have dz equal P. What is P? A times 1 plus 1 by x dx. What is Q? Minus A. 1 plus 1 by y dy. This is it. You have found P, you have found Q. So dz is equal to P.D.E plus Q dy. So substituting for P and Q, this is it. Now let me integrate. I have z equal A x plus log x minus A y plus log y plus some constant integration, say b. So this is the solution. Or you can write it in this form. Z equal to A x minus y, this one and this one, then A log x minus log y plus b. So this solution contains as many constants as the number of independent variables. So this is the complete solution. Okay. You see, you must be knowing this. Dz equal P.D.E plus Q dy. If we don't, let me tell you how do we find it. I've already shown you in your first semester how to find it. Let z equal to function of x and y. Then what is z plus delta z? It is f of x plus delta x, y plus delta y. Let me subtract the two. I will get delta z equal f of x plus delta x, y plus delta y minus fxy. Let me add something and subtract something from it. You see, this is delta z equal f of x plus delta x, y plus delta y minus say f of x, y plus delta y. Okay, this is it. Now I have subtracted x, y plus delta y. Let me add up f of x, y plus delta y, and I have this minus f of x, y. These are two things now. I can subtract. I have added this and subtracted this. This is only f of x plus delta x, y plus delta y minus f of x, y. Now let me multiply this by delta x divided by delta x. This delta y and delta y, and taking limits as delta z approaches 0. When delta z approaches 0, delta x and delta y will also approach to 0. You will get dz equal. This is nothing but this is partial derivative of z with respect to x. F for z, it is same because z is for f. And this is dx. See, x is changing, y is same. Similarly here, x is same, y is changing. So this is partial derivative of z with respect to y. And this is dy. That is why I will be using this only. Dz is equal to delta z by del x dx, delta z by del y dy, which is P.D.E, and this is Q dy. I will be using in all the forthcoming forms. Okay, now let me take up one more question. Let me have p minus 3x square equal p minus 3x square equal q square minus y. Okay. So see, You have P on one side with X, Q with Y. So let me suppose that they are equal to A. You can take A square also, A cube also, log A also. It depends on the question. Now this gives us P is equal to A plus 3x square and Q is equal to Y plus A raised power half. Now I know dz is equal to P.D.E plus Q.D.Y. This is equal to A plus 3x square dx Y plus A dy. So let me integrate, raise power half, sorry. Let me integrate it. Your z is equal to ax plus 3x cube by 3 plus y plus a raised power 3 by 2 divided by 3 by 2 plus some constant integration b. So this is ax plus x cube plus 2 by 3 y plus a raised power 3 by 2 plus b. This is it. This is the complete solution containing as many constants as the number of independent variables. So you will have more questions. I will be sending more questions to you for your practice. Let me take up one more example, this form, which is f of pq. F of pq equals 0. Only p and q will be present. No x, no y, and no z. Now how to solve such equations? We put, what is the solution? We put q equal to a. You can also put p equal to a, doesn't matter. When you have q equal to a, you will get f of pa equals 0. This will give us p as function of a. So again, you use dz equal P.D.E plus Q.D.Y and solve it. This is it. This will contain as many constants as the number of independent variables. For example, you have say p square plus q square equal to 1. This is a non-linear partial differential equation, and wherein p and q are present. No x, no y, and no z. So let me suppose put q equal to a. Then what is p? It is 1 minus a square under root. Plus minus you can say, doesn't matter. P square is 1 minus q square, it is 1 minus a square, so p is plus minus this. Now, what is dz? We know dz is equal to P.D.E plus Q.D.Y. It is 1 minus a square dx plus a dy. Now let me integrate it. Z is equal to 1 minus a square x ay plus some constant integration b. You can see this is a differential equation. Yes, this is a solution containing as many constants as the number of independent variables. So this is the complete solution. You could have put p equal to a, then this would have been ax square plus minus under root of 1 minus a square. Doesn't matter. Okay. Next one, let me have p plus q plus pq. P plus q equal to pq. So if we choose q equal to a, this is again pq form. I will get p plus a equal pa, or p equal a upon 1 minus a. So what is dz? P.D.E plus Q.D.Y. It is a upon 1 minus a dx a dy, which gives us z equal 1 minus ax ay plus b. Complete solution. This is very easy. Let me take up now f of p, q, and z equals 0. You have now three things: p, q, and z. So let me take up, see how to solve such equations. First of all, we put Q equal AP. Instead of P, we put AP. The reasons why do we do this, I will be sending notes to you. So I will get f of P, AP and Z equal 0, which will give me P equal some function of Z and A. Simple. I have put Q equal AP. I have P, AP and Z. So you have three things, P, A and Z. Now let me solve it for P. P will be function of Z and A. I have P, I have Q. So I have dP, dz. What is dz? P.D.E plus Q dy. But my Q is AP. So this is P times dx plus A dy. Or dz or dx plus A dy, I can write it right away. If I put Q equal AP, then dx plus A dy will be dz upon P. And you know what is P? P is function of Z. I can integrate it and solve it. Okay. Or I can write dx plus A dy equal dz by function of Z and A. Integrate and get the solution. This is it. This is how do we do such questions. Let me take up a question. Say I have Z equal P square minus Q square. So Z is function of P and Q. So I have P, Q, Z. So let me put Q equal AP. What I will get? Z equal P square minus AP square. So P square equal, or P square into 1 minus A equal Z. So P is equal plus minus root Z upon root 1 minus A. Okay. So P is Z upon, P square is Z upon 1 minus A. So P is plus minus root Z upon this. Now I will not use this one now. I will use this one. I know dx plus A dy equal dz by P is equal dz by plus minus root Z upon 1 minus A. Or dx plus A dy equal plus minus Z raised power minus half dz into 1 minus A. So let me integrate it. I will get x plus ay plus some constant integration. Whether we write it on the right hand side or left hand side doesn't matter. This is Z raised power minus half plus 1. Half by half, so it is twice root of 1 minus A. Okay. X plus A y integration of Z raised power half. Z raised power minus half plus 1. It is Z raised power half by half. So it is twice. So or this is a solution, complete solution. It contains as many constants as the number of independent variables. Or you can write in this form, x plus ay plus b whole square equal 4 1 minus az. This is it. You are at liberty. How do you write the solution? Let me take one more question. Say you have ZPQ equal P plus Q. Okay. ZPQ equal P plus Q. So let me put Q equal AP. This is ZPQ form. So it is ZP AP equal P plus AP, or ZP AP equal P1 plus A. So P is equal to 1 plus A upon A by Z. Okay. P is equal to 1 plus A upon AZ. Okay. Now we know dx plus ADY equal dz by P is equal to dz upon 1 plus A by AZ, or dx plus ADY is equal to AZ dz upon 1 plus A. So let me integrate it. I will get x plus AY plus B equal to A upon 1 plus A Z square by 2 plus C. This is it. You can have as many questions as you know, as you will find in the book. I will be sending the notes. Now, let us suppose that I don't know all these methods. So, I will now tell you something about Charpit's method, which solves non-linear differential equation of the form x, y, z, pq equal to 0 directly. You can use it directly, and you will find the solution of all the standard forms, which these four standard forms. Now, how to solve this is a very big article. I will not be showing this article, but I will be using Charpit's auxiliary equation only. Charpit's method for solving non-linear partial differential equation f x y z p q equals 0. You see, what is the working rule? Working rule is that write down the Charpit's auxiliary equation. What is Charpit's auxiliary equation? It is dx by, you see, you can find this is x, y, z, p and q. You can find dx, dy, dz, dp, dq. So I will write dp by, dq by, dz by, dx by and dy by. You can see the article. I will be sending it to you, but I will not be using it. But I will be using only this auxiliary equation, which I will write over here. See, you will have dp. You have function f, x, y, z, p and q. You can differentiate partially with respect to x, y, z, p as well as q. I have to use those partial derivatives over here. You have dp by del f by del x plus p del f by del z. This is dp. dq, you have to remember del f by del y, then q del f by del z. Then you have dz by, now no x, no y, no dx, del f by del x, no del f by del y. What is there? It is minus p del f by del p minus q del f by del q. Then dx by this one minus del f by del p and dy by minus del f by del q. This is the Lagrange's Charpit's auxiliary equation. I will be using this only to solve all such equations, whether it is f of x, y, x, p, y, q, it is x, y, z, p, q, or it is f of p, q equals 0, or it is f of p, q, z equal to 0. All the formats and some other questions which are not of those standard forms which I have shown you right now. Let me take up a question which you already have done. Say, or a question of this form: q square equal q equal 3p square. You know, this is pq form. This can be easily done with the help of function of f pq equal to 0. You have to put q equal to a or p equal to a. You will get, when you put q equal to a, you will get p, or you will get p equal to a, you will get q, and then you use dz equal to pdx plus q dy. Now let me solve it with the help of Lagrange's form. Let me suppose that this is a. Now let me find out this is, say, q minus 3p square equal to 0, and let me suppose that this is function of x, y, z, p and q. Okay, q minus 3p square or 3p square minus q, doesn't matter. So this is equal to 0, and this is function of x, y, z, p and q, while x, y, z are not present there. So you can find out del f by del x, del f by del y, del f by del p, del f by del q, del f by del z, because all these things you need in this a. Now from a, what you will get, if you use del f by del x, you know del f by del x is 0 because you don't have x. Del f by del z is 0, del f by del y is 0, del f by del z is 0. Okay, but you have del f by del p, you have del f by del q, so you will get these two 0 denominator, and you will get rest of the things over here. I need some things or don't need some things, so let me have only those things which I need. Okay, so this will be dx by p, sorry, p by 0, dq by 0, then dz by something, dx by something, dy by something. Okay, I don't need all these things because from this or this I can have q equal to a. When denominator is 0, so is the numerator. So dq equals 0 means q equal to a. Or from this I can have p equal to a. So when q equal to a or p equal to a, you have your choice. Whether you take p equal to a or q equal to a. You can have q equal to a also. This is the solution, q equal to a. You have q equal to a, what is then p? This is 1. This is question. Q equal to 3p square. So from 1, now if I am taking p equal to a, when denominator is 0, so is the numerator, I have the solution, p equal to a. Let me have this p equal to a. I can have q equal to a, doesn't matter. Now from 1, when p is a, q is equal to 3a square. So I have p, I have q, I know dz is pdx plus q dy. So what is my z? P. I have ax plus 3a square y plus b. Constant integration. This is it. You know, this I could have solved this equation with the help of f of pq equals 0, and same answer would have been there also. So whether you know that formula or not, doesn't know that formula, you know this, you can have the solution. Next. See, let me take up zpq equal p plus q, or you have, this is a zpq. This question I have done right now a few minutes back. Let me write down, this is a function of f of p, q and z, or this is z pq minus p minus q equals 0, and this is your function of x pq, or you can write p plus q minus z of pq equals 0. Okay, now you can use it in a. From a you will get, what you will get from a, you can have all these functions, del f by del x which is not there, del f by del z which is there, del f by del y which is not there, del f by del z which is there, and rest of the things. So I will take only two things, dp and dq. dp by dq by. Now, what is dp by? See, del f by del x, it is 0. Then p del f by del z. Let me differentiate this partially with respect to z. When I differentiate partially with respect to z, I will get pq only. So this is p is there already. So this is p square q. Now, del f by del y, it is 0. Q is already there. Del f by del z, I have pq. So it is q square p equal dz by something, dx by something, dy by something. Now let me take up these two fractions together. What I will get? Q square p dp, p square q dq, q square pq pq, pq pq. So you have dp by p, dq by q, or you can integrate it now. You will have log p log q plus log of a. So p by q equal a. So p equal aq, or you can have q equal to ap. See, you see, when I had z pq equal 0, I was taking q equal to ap. So when q is equal to ap or p equal to aq, I can share it in 1, find p and use the formula. Okay. This is simple. So you have p. Let me substitute in first. I will get from 1 z p is a q square equal p is aq plus q. So z a q equal a plus 1. So q is a plus 1 upon az. You see, I have shown you this question with the help of that standard form. Now dz, or now I have, okay, dz pdx plus q dy. Your p, what is pure p? aq. aq dx plus q dy. Or you have adx plus dy dz by q. And you know your q is function of z. adx plus dy dz upon q. What is your q? What was q? It is 1 plus a upon az. Easy. Okay. So I have ax plus b, sorry, y plus some constant integration equal 1 plus a z square by 2. This is it. Earlier I had a plus, instead of ax, I was having x plus ay. Doesn't matter because I had put p equal to aq. Here q equal to ap. Here I have p equal to aq. This is how you will take. If you had taken the second fraction, you would have got q equal to ap. So this is it. You will be having hard problems. You will not be having such easy questions also. I will be sending you the notes. You please go through those notes. You will get. I think I have finished my job on partial differential equations. However, I will be telling you one more simple method of solving a partial differential equation by the method of inspection. Let me show you a few questions on that. Solution by inspection. By inspection. These are very easy questions. Say you have r equal sine xy. You see, r is function of sine xy, z is function of xy, r is function of xy. What's r? You know r is del 2z del x2 sin xy. Now let me write it in this form. Del by del x of del z by del x equals sine of xy. Now let me integrate it. I have to find z. Let me integrate it with respect to x. I will get del z by del x. Integrating with respect to x. Differential integration goes. What's integration of sine? It is minus cos xy. What is the constant? When you are integrating with respect to x, y is the constant. So, you know, integration of sine of ax, it is minus cos of ax by a, while a is constant. Here, when you are differentiating or integrating with respect to y, your x, your y is constant. Plus some constant integration. What is that? It will be function of y. Why? Why function of y? Because you are integrating with respect to x. So function of y will be constant. If you will differentiate again with respect to x, this will go and you will get the solution. Again, let me integrate with respect to x on again. I will get z equal to minus 1 by y. This is constant because I am integrating with respect to x. Cos of function minus. So it is sine of function divided by constant, it is y. Then integration of function of y with respect to y and constant integration, it will again be a function of y because you are again differentiating or integrating with respect to x. So your solution is minus 1 by y square sine of xy plus some function of xy. This will be after integration some function of xy and some other function of y. You see, if you have this question and I am asking you to find a partial differential equation, you will differentiate it twice with respect to x, you will get this thing. This is solution by inspection. Next one. I will show you 2 or 3 questions. The rest you will do it yourself. Say you have S equal to S equal to x1, doesn't matter. Or x square y square, doesn't matter. What's S? Del 2z del x del y. X square y square. Now, this can be written as del by del x, del z by del y. Now, you have to integrate with respect to x. With respect to x, y is constant. You will get del z by del y. You are integrating with respect to x, x cube by 3 y square. Now you are integrating with respect to x, so function of y will be constant. Fine. Now you have now function of y, del z by del y. So you will integrate with respect to y. Integrate with respect to y. You will get z equal x cube by 3 is constant because you are integrating with respect to y. Y cube by 3 plus function of y with respect to y, and constant integration will be some function of x because you are integrating with respect to y. This is the solution. You can put it like this only, or you can write x cube y cube by 9 some other function of y, say capital F of y and psi of x. Okay, let me take one more question. Say you have xr equal to p. What's r? You can write it as del r. R is with respect to x. Okay. Now del z will x. What is that? It is p. Let me separate the variables. You will have del p by p, del x by x. Integrated, I will get log p equal to log x. You are integrating with respect to p. P is a function of x. So, some function of y. Constant integration will be some function of y. So what is P? X by function of y. You can have log of function of y also. Okay, let me write it as log of function of y. So you can have x log function of y. Sorry, log x plus log cancels out x function of y. Okay. Now what is P? Your P is del z by del x. X function of y. Now let me integrate with respect to x. I will get z x square by 2 function of y plus some other function of y because you are integrating with respect to x. Okay, this is very simple. Now let me take up one more question. Say I have xr plus p. Nine x square y square. xr plus p. You see this is x del 2z del x2 plus p equal 9x square y square. This is x del p by del x plus p 9x square y square. You see? This is del p by del x because del 2z del x2 I have just now shown you that this is del by del x del z by del p, which is del p by del x. Okay? Or del p by del x 1 by xp 9x y square. Now let me integrate with respect to this is dy by dx plus py equal to q. So integrating factor e to the power p dx e to the power log x, which is x. The solution is y into integrating factor equal right hand side into integrating factor plus some function constant integration function of y. Okay, xp equal 9x cubed by 3 y square plus function of y. Or you have x 3 p equal 3x square y square plus function of y by x. What is your p? Del z by del x. Now integrate it once with respect to x, you will get the solution. Okay, I will take your leave now. I will be taking up Fourier transform in my lecture. Thank you.